This is the second video on cleaning, but to understand how we clean the other apparatus, we need to understand how a titration works. We know from the previous video that we put our standard solution inside our burette, and that's got a precisely known concentration. We know the concentration of that standard solution. We have our unknown solution down inside a conical flask, and we have a very precisely measured volume of that unknown in the conical flask, and it's the concentration of that which we're trying to figure out. We're trying to figure out the concentration of that unknown. We've also got an indicator in here, which is why it looks a little bit yellow. And what we do in a titration is we actually open the tap of the burette and let the standard solution run out into the conical flask while we're swirling the conical flask. What we're looking for is the point at which the indicator changes color, because if we've chosen our indicator correctly, that'll change color at the point at which that unknown has been completely neutralized. And at that point, we turn off the tap and we actually measure what volume of standard solution was required to actually neutralize that unknown. And because now we know the volume and the concentration of the standard solution, that means we know exactly how many moles of standard solution there were required to neutralize that unknown. We can then use our stoichiometry, the equation stoichiometry, to figure out how many moles of unknown there were in our conical flask. And if we know the number of moles of the unknown, and if we know the volume of unknown in the conical flask, we can then figure out the concentration of the unknown, because concentration is just number of moles divided by volume. So if we know the number of moles of the unknown, and we know the volume of the unknown, we can find the concentration of the unknown, which is the whole point of the titration. But that means, for this to be right, that means we've got to be very careful how we put this unknown inside this conical flask to make sure that we do have the right volume inside that conical flask, and also to make sure that the volume in our conical flask has the same concentration as the bulk volume that we're actually trying to measure the concentration of. So let's see how we do that. So we might have our unknown inside a sample. We're not going to test the whole lot at once in our titration. We're going to test a small amount in our titration to figure out the concentration of what's left behind, which means we need to make sure we transfer a fixed number of moles of this unknown into our conical flask. And the way we do that, we've got to be very careful how we do that. How can we transfer a fixed number of moles? How we do that is by measuring a fixed volume. We actually take a certain volume of our unknown into the conical flask. It's usually 25 mils. We put inside the conical flask, which is measured using a 25 mil volumetric pipette. So we use the pipette to make sure we've got a precisely measured volume. As long as the concentration doesn't change, that means we're putting a precise number of moles. Even though we don't know what that moles is, we're putting a precise number of moles into that conical flask, which means we've got to be very careful in using the pipette properly to measure that 25 mils. It also means we've got to make sure we keep that concentration constant as we go from the sample to the pipette to the conical flask, because if we change that concentration somewhere on the way, the results of our titration will not be giving us the actual real concentration of our unknown solution. So similar to when we cleaned our burette, everything we put this unknown into, up into the stage that the pipette has to be cleaned properly. So what we usually do is we put some of that unknown into a beaker, and then from the beaker we draw that unknown up from the beaker into the pipette. But we've got to make sure that we make it clean. So first of all, we clean the beaker out with water, and we clean our pipette out with water to make sure there's no impurities inside there. But if they're cleaned out with water, obviously they're going to have some water residue inside. So we've got to clean both with our unknown solution to make sure we're not going to dilute the unknown solution once we put it inside them. So once we've cleaned our pipette and beaker out with the unknown solution, we can assume that we're not going to dilute our unknown, and then we can put the unknown solution in the beaker. We can then draw up that unknown into the pipette. We can fill it right up to the 25 mil mark, and that means we know we've got exactly 25 mils of our unknown in the volumetric pipette, and we know the concentration has not changed. From this point on, we now have to transfer this chemical from the pipette into the conical flask. And what's important, as we said before, when we're transferring this chemical, is we're transferring a fixed number of moles. And we do have a fixed number of moles inside this pipette. Okay, the reason why it's fixed is because we've got a fixed concentration, which is the concentration was at the start, and we've got a fixed volume inside the pipette too, which means we've got a fixed number of moles inside the pipette. So when it comes to transferring this from the pipette into the conical flask, we've got to be very careful how we clean the conical flask as well. So the first thing we do is clean it with water to make sure there's no impurities inside the conical flask, which could change the concentration of our solution. But in actual fact, with the conical flask, that's it. We don't wash the conical flask out with the standard. That's not done. We don't do that at all. And the reason being is if we washed our conical flask out with this unknown chemical, that would then add some excess moles, some extra residue, would be extra moles of the unknown inside the conical flask, which when we transferred this fixed number of moles into our conical flask, it would be a fixed number of moles plus some extra moles we didn't take into account when we washed the conical flask. So when it comes to the HSC, it's very important you know, volumetric pipette, it's washed with water and then the chemical that's going to be used inside the pipette. When it comes to the conical flask, we only wash it with water and that's it, because we can't afford to have any extra moles of chemical inside our conical flask. So once we've transferred that unknown from the pipette into the conical flask, now we've got the unknown inside the conical flask. It's 25 mils of unknown and its concentration hasn't changed from the start. The next thing we do is add our indicator, which is in this little bottle down here. And the reason we add the indicator is because we want to see when the color changes in our titration. So we add the indicator in there and that's ready to go. That indicator doesn't change the number of moles of the unknown in there, so that's fine. And what you do is when we're running the titration, we look for the point at which the indicator changes color, and that's the sign for us to stop the titration. The point at which the indicator changes color is called the end point, and that's when we stop the titration. And if we've chosen the indicator correctly, that end point will match up with what's called the equivalence point, which is the point at which we've added the exact right amount of standard solution to exactly neutralize that unknown, and therefore we can use our equation stoichiometry to figure out the moles of standard, the moles of unknown, and therefore the concentration of the unknown. So the last thing, just to clarify, it's very, very important, the pipette is washed out with water, and then the chemical going to be used inside it, so we don't dilute that chemical. The conical flask is washed out with water only, so we don't add any extra moles into that conical flask. As we said on the previous slide, the burette, similar to the pipette, is washed out with water and the chemical going to be added into that burette.